Troubleshooting. One of the best skills you can have as a subsea engineer. When you know your equipment well enough to be a good troubleshooter, you'll be able to keep downtime and costly repairs to a minimum. These two gauges will be your primary indicators of valve trouble: readback pressure and pilot pressure. The readback gauge is teed into each HKR at the valve itself, or in the supply line just downstream. The pilot pressure gauge reads pressure in the pilot line between the AKR and HKR. Pilot pressure is actually the output pressure of the AKR, not the supplied air pilot. When your stack is subsea, these two gauges in conjunction with your flow meter are your only indicators of regulator malfunction or loss of integrity elsewhere in the hydraulic circuit. Though this program deals specifically with regulator problems, it's important to look at a complete basic circuit to see how all functions play their part under normal circumstances. Let's isolate a single circuit from top to bottom and illustrate it for you. Surface accumulators, stack accumulators, AKR, HKR, SPM, shuttle valve, ram. As we mentioned earlier, the readback pressure gauge is teed in here at the HKR, and the pilot pressure gauge is teed in here at the AKR. First, we'll assume normal circumstances to show you where everything should be. Then we'll start springing some leaks around the valves and watch the gauges and flow meter. Let's say that normal operating pressure is 1500 psi to close that ram. So we regulate pressure from the HKR to 1500 psi. Supply pressure to the HKR is 3000 psi. Now the output pressure of the AKR must be 1500 psi to regulate the HKR output. With a 30-to-1 ratio AKR, that means the air pilot pressure must be regulated to 50 psi. The ram is open with the ram's close SPM blocking flow to the closed side of the function. The flow meter reads no flow. The readback and pilot pressure gauges both read 1500 psi. The driller closes rams. The closed ram's SPM opens and allows flow to the function. The open SPM closes and vents the open function. When the ram is closed, the flow meter reads the number of gallons it took to close, whatever that volume is. As the close SPM opens, the readback pressure gauge will drop as the fluid flows through the HKR. The gauge will reflect some pressure as a result of friction in the lines and ram. Pressure builds up as the resistance to flow increases. As it does, the readback pressure gauge rises again. When the pressure reaches 1500 psi, the HKR closes, blocking off supply pressure and holding 1500 psi to the function. Since the HKR is maintaining 1500 psi, the rams are also held closed with 1500 psi. As you know, there are many potential trouble spots in and around the regulators: the seal rings, the seal plates, any O-ring or backup ring, the valve fittings or flanges, etc. Let's look at the HKR. Suppose there's a leak or trash in the vent system. The readback pressure gauge will decrease at a rate that reflects the size of the leak and then shoot back up to the normal level. The pilot pressure gauge remains steady. The pattern will continue. Depending on the size of the leak, the flow meter may be ticking off also. If it's a small leak, chances are you won't see it reflected on the flow meter. The leak is causing the pressure in the valve body to decrease slowly when it's not supposed to. Eventually, the pressure inside the valve body drops low enough that the seal container shifts open to allow more inlet fluid. The readback gauge then jumps back to normal. Run the regulator through a range of pressures a few times. That should blow out any trash in the vent system if that's the problem. If a leak is in the valve, it's in one of two areas: around one of the valve body flanges, or in the valve vent system. If it's in the vent system, the vent seal rings or O-rings around the vent seal rings are bad. If it's one of the poppet valves, maybe the poppet or poppet seals are bad. Now, you can repair that without removing the valve from the stack. Simply remove the pilot valve body and poppet and you'll hold the entire vent system in your hand. Either the seals, pilot valve seat, or Teflon tip is bad. Of course, keep in mind that the size of the leak will determine how fast that gauge moves. If it's a very slow leak, it may take an hour or two for the vent system to bleed down enough to cause the internal pressure to drop to a point where the seal container moves open. Slow leaks are much harder to pin down since the valve takes longer to react to them. A fast leak, on the other hand, is much easier to spot since the valve reacts more definitely. Now, if the readback pressure gauge drops, never recovers, and the flow meter ticks off a steady volume of fluid, then you have a serious, free flow sort of leak. Let's move a leak inside the valve body. Say the seal rings, plates or O-rings around the seal rings are leaking. What'll happen? The readback pressure gauge will rise slowly, then fall to the normal level and repeat the pattern. The pilot pressure gauge will remain steady. Supply fluid is slipping past the O-rings or sealing edges into the valve body. This causes an increase in body pressure. The readback gauge rises to reflect this. Eventually, the overpressure causes the seal container to move up, and the valve vents until the pressure is again back down to the pilot pressure setting. That pattern continues. Meanwhile, the flow meter may be detecting a flow. Another possibility: trash in your system once again. Run the regulator through a range of pressures a couple of times. This should blow out any trash in the valve. Here's one for you. Suppose you have a leak around the inlet flange or in the supply line upstream of the regulator. Both gauges should remain steady, but the flow meter ticks off a constant flow. Then the pumps keep kicking in. Since there is a leak upstream of the regulator, the system must keep supplying fluid to keep the pressure up to 1500. If it's a flange leak, chances are the flow won't be much, and you may not even be able to detect it readily. If it's a line leak, though, the fluid may be flowing faster. Suppose the plunger guide O-rings leak. In an overpressure situation, your supply pressure may flow into your pilot line instead of out the HKR vent system. The readback gauge will rise in response to the overpressure, and the pilot pressure gauge will start to rise shortly after that. That's because the pressure is also building up at the AKR. If the AKR is working properly, it'll detect this overpressure and dump it to tank. In other words, the overpressure in the HKR is venting through the surface AKR. Let's create some leaks in the surface AKR. If the vent system is leaking somewhere, say around the vent seals, or there's trash in the vent system, pressure in the valve body will decrease. When the AKR detects this change, it'll open to allow more pilot fluid in. So the pilot pressure gauge will drop, then jump back to normal, and the pattern will continue. How will the HKR react? Well, it will mirror the AKR. As the output pressure of the AKR drops, the HKR will drop in response. When the AKR output pressure jumps back to normal, so will the HKRs. Of course, the readback pressure gauge will reflect these changes. Again, run the regulator through a range of pressures. This will blow out any trash that could be the cause of the problem. If that doesn't work, you've got a leak in the vent system. What if the internal seals in the AKR are bad? The inlet hydro seals, or the rubber goods around the inlet hydro seals. Inlet pressure leaking into the valve body causes an increasing overpressure. As the valve detects this overpressure, it vents the necessary amount of fluid to bring the valve back into pressure balance. The pattern continues. So the pilot pressure gauge rises, then jumps back to the normal level again and again. The HKR? The valve and the readback pressure gauge will mirror the AKR. A reminder, if you have to replace an internal seal ring or plate in either the HKR or AKR, put in a complete repair kit. Now examine a leak in the air pilot system. Say the diaphragm is leaking. The pilot pressure gauge will drop and remain low. The readback pressure gauge will fall in response. You've got to act fast. A loss of pilot pressure is most dangerous. If the rubber is leaking, you may be able to detect air coming out of this hole in the bottom cover. If no luck there, check around the rim between the top and bottom covers. Use soapy water to detect an air leak there. If the rubber diaphragm checks out okay, the problem's in the air lines, the check valve on the increased solenoid, or the vent seal in the decreased solenoid. If you lose air pilot pressure completely, all AKR pilot pressure will vent to tank. All function pressure will vent to sea through the HKR. So that takes care of the most common problems you'll have with these valves. You could probably go on for hours if you considered every possible combination of leaks. For instance, suppose there's a vent leak in both the AKR and HKR. The body pressure in the AKR and the pilot pressure gauge will decrease. In response to that, so will the readback pressure of the HKR. In addition, since the HKR vent is also leaking, the readback pressure will drop even further. So if you assume 1500 psi is normal, you might have the pilot pressure gauge read 1400 and the readback pressure gauge read 1350. As each valve senses the internal pressure drop, they'll open to allow more inlet fluid, and the gauges will move back to normal. Suppose there's an inlet seal ring leak in both the AKR and HKR. The body pressure in the AKR will increase slowly. The pilot pressure gauge will reflect this. In response, the HKR readback pressure will rise identically. Further, since the HKR seals are also leaking, the internal pressure will rise even farther until the valve vents the overpressure. What would happen if the vent system was leaking in the AKR, but the seal plate was leaking in the HKR? Or what about a vent leak and plunger seal leak in the HKR? Well, the list goes on. Think about these and see if you can solve the problem. You've spent some time with us now fine-tuning your knowledge of the Koomey regulators. You've learned how they operate, what goes wrong, and how to repair them. At the very least, you know which gauges indicate trouble. The gauge that varies first, pilot or readback, most often indicates the faulty valve. If pilot pressure changes first, the problem's most likely in the AKR or related equipment. If the readback gauge moves first, the problem's probably in the HKR. The MKRs, of course, have no pilot signal, but they do have the same readback process as the HKRs. Leaks in an MKR will be indicated on their readback gauge just as the HKR readback gauges reflect valve trouble. So that's it. By now, if you've viewed all the regulator programs, you should have a good idea about how they behave. Of course, the best teacher is experience. These problems are going to occur. Single valve leaks are the most common, and we've covered all those. On rare occasion, you'll run into one of those multiple seal leaks. Learn how to handle either situation. Troubleshooting, the best skill a subsea hand can have.